In this video, we're going to be going over the solutions for the short answer questions, or what I like to call full process questions from the group circles test. All right, so let's go ahead and get started. So the question I want you to think about first is, what shape do we have here? And if you correctly said a prism, that is right. It is a prism. And you remind yourself that the volume of a prism is area of the base times the height of the prism. You can see here the height of the prism is 7.5. So we need to figure out next what the area of the base is. And I always call this shape. It's curved here and straight here. It's a pizza. Okay, so it's a sector. And we remember that the area of a sector is some fraction of the area of a circle. So this is how we're going to go solve the volume of this piece. We know that the central angle here is 30, so we're going to plug that in, and immediately, 30, I can see that I can reduce that fraction, which is kind of cool. I see that the radius here is 10, so it's 10 squared, and I can see that the height is 7.5. So I'm going to do 1/12. Before I even grab my calculator, pi 100, 7.5. Okay, so at this point I'll grab the dumb calculator and type some of this in. 100 times 7.5 is 750. And of course my calculator didn't type it correctly. 750 times pi divided by 12. And here we get the answer. 196, and we round to the nearest hundredth there, so it's 3.5. And my units are centimeters, and volume is cubed. So I've got the right units, and there's my answer. So once again, this was a prism, and the key part of this one is that we had to get the area of the base, and the base shape was a sector of a circle, piece of pizza. On question 17, this time they gave us the arc length. Up here they gave us was 6. And you might remember arc length formula. Arc length is equal to some fraction of a circle times the circumference. Okay? And what they did is they actually gave us the arc length, which is 6 pi, and we're going to work backwards. They gave us here that the arc is 72, so that means the central angle is also 72. And we're trying to find the radius right there. All right, so first thing I can see is there's a pi on both sides, so let's just divide through by pi. And let's divide, I don't know what else through. We can, I don't know, do we put it in the calculator at this point? Let's multiply both sides times 360 to get rid of that fraction times 6. And I get 2160 equals, and 2 times 172 is 144 r. Therefore, we divide that by 144, and we get 15. 15, and no units, just 15 units. So the radius of that circle is 15 thingamabobs. All right, coming up next, we're looking for the measure of this arc right here, okay? That's what we're looking for. And that's going to be the same as any of its included angles, which there aren't really any included angles. But we know that if I can find this, that arc plus that arc equals 180 because that's a half circle. So my guess is I'm going to go find the measure of this arc. And I'm going to do so, we know the inscribed angle. And so you take the measure of the inscribed angle and you multiply it times 2, and it will give you that. So let's go ahead and do that now. And here we're going to get 4z plus times 2 is 8. So I took the inscribed angle here, multiplied this times 2, and got that. Now we see that this is a half circle. So that means this plus this over here equals 180. 4z plus 8 plus 16z plus 12 equals 180. So that half circle's arcs add up to 180. I add the z's together, I get 20z. Add 8 and 12 together, and you get 20. How about 20z equals 160? Z equals 8. And so it's going to be the same as this one. So I just plug in 8 into 16 like this, plus 12. 16 times 8 plus 12. And we get 140. So that arc is 140 degrees. All right, what's the length of SQ? A lot of people did this one wrong too. The tangent squared, 6 squared, equals the exterior part of the tangent, of the secant, times the whole secant. And a lot of people just put 5x here. It's actually, the whole secant is x plus 5. Please, this and this adds up to 5 plus x. And from there, it's a quadratic, it looks like. So I get 36 equals 5x plus x squared. Since it's a quadratic, we bring everything to one side and factor it. So I'm going to put it in order, x squared plus 5x. I typed something wrong here. 5x minus 36. And it factors to, what is that here, plus 9. X minus 4, so that means x is equal to 4 and negative 9. And you realize you can't have a length that's negative, so we cross that one out. So what is the length of SQ? SQ is equal to 4 plus 5 equals 9. There it is. All right, in our next problem here, we're looking for the angle TQR. Or that angle right there. Since this is a quadrilateral, we're going to go add all 4 of these angles up, and they will be equal to 360. A lot of groups mistakenly said this angle was x, and it's not true. We do not know that. But we do know this. How about if you take a look here? I'm going to draw a line right there. I don't even know if you need that line. Probably not. Let's not draw a line there. But take a look here. This angle is the inscribed angle on that arc. And this angle over here is the inscribed angle on that arc. So that arc plus that arc equal 360. That means their inscribed angles half as much, equal 180. So I'm going to do 3x plus 5 plus 5x plus 15 equals 180. And combine like terms, 8x plus 20 equals 180, 8x equals 160, x equals 20. And now we have to go answer the question. I think what we need to do is go find the answer to each one of those angles. So we plug in 20 here and we get 75. Plug in 20 here and we get, what do we get? 20, 80, 110. And plug in 20 here and we get 65. So we know 3 of the angles, we're going to call this y. 65 plus 110 plus 75 plus y equals 360. Once again, all the angles in a quadrilateral add up to 360. Let's go find y. And so I'm just going to type that in here. 360 minus all those angles added up, which is 65 plus 110 plus, oops, I only put 6. 65 plus 110. It's the other one plus 75. And indeed, let me just double check that answer, is 110. I've just noticed I made a mistake. Here it was 5 times 20 is 100 plus that is 115. So this one should be here. 115, and when I solve it on the calculator, I get 70 degrees. Okay, sorry about that mistake. I knew the numbers were looking slightly different than what I remembered. All right, number 21. The key thing here, there's a little theorem that says, let's call this x, a little theorem that says this arc and this angle right here, this angle will be half as much as the arc right here. So 100 degrees is equal to half of 150 plus x. So let's, and we are trying to find PQ, we'll find that later, but first thing we're going to do is go find this x. So that's going to be, let's multiply both sides times 2 to get rid of my fractions. And I get x is 50. Okay, once I have x is 50, I'm looking for PQ, and we're going to call that y. Call that y. So I know that all these arcs in the circle add up to 360. So 150 plus 45 plus y plus 50 equals 360. And, oh, did I forget a 0 there? Forgot a 0 right there. Okay, that looks good to me. And I get 245 plus y equals 360, or that y is equal to 115. There's the answer for PQ. All right, let's go do the extra credit now. We want circles that have a tangent to the line y equals 3. So the first thing I do is I go draw a little thing here, 1, 2, 3, and there's my tangent line that I want. And so by looking here, this is 16. So that represents radius squared. So the radius is 4. So what I want are circles that have a radius of 4. So you can see I can count here if I want a tangent. 1, 2, 3, and then at -1, I'm going to come down. And we know that the x value is 0 because it doesn't have an h value. So we're going to go draw that in. And that has a radius there of 4. And that value there is 0, -1. So that k can be -1. But also we can do another circle above it. So we're here at 3, 4, 5, 6, 7. I put the center of my circle there. And there's another circle that is tangent to the line y equals 3. So k can be either -1 or 7. All right, and wrapping this up quickly, I only have, that only lets me do 15 minutes. This one got longer. We're going to plot these points here quickly. And I get 1, 5, 2, -2, and -6, -2. You can see in this triangle, like the other day, we talked about it, the perpendicular bisector is going to go through that midpoint there. And since this is a horizontal line, this is a horizontal line here. So I can quickly get that point, and the midpoint halfway between -6 and 2 is, that point there is -2, comma, -2. Okay, so I know that that's one of my perpendicular bisectors. And if we want equal distance from the 3 cities, we're going to be going and finding the circumcenter. So finally, center. What we're going to go do is to go find the perpendicular bisector of another one of our sides. And I'm going to go do this side. This side up here is 1, 5. And we're going to find that the midpoint right here is actually 1.5, 1.5. And that's going to be useful. I know that this slope, you can figure it out. This slope is -7. So if the original slope of the line is -7, the perpendicular slope of the line is -1/7. So to go find this perpendicular bisector, I'm going to go use the formula. Sorry, I'm going a little fast to wrap this up. X. I'm going to plug in this point here into x and y, go find B, and then see where the value of y is when x is -2. So that's it, folks. The correct answer here, I believe, is -2, 1. See me if you want to go through this problem more. All right, thanks a lot.